Excellent. I think that brings us up to about time for another question for you gentlemen. So what are some of the key challenges IT organizations face around security analytics and forensics in light of megatrends such as multi-gig networks, KPIs, business intelligence, virtualization, data center consolidation, cloud, and big data? All the buzzwords.
So this is Jim. I'll start with one of those. Certainly we could spend the whole day talking about probably each one of those in its turn, but why don't we try to bite off a couple of those. Let me talk a little bit about some research results we had, in particular around virtualization and the influence and the sort of negative influence that virtualization technologies are having on visibility and the types of techniques we've been talking about today. So we asked, how folks had gone about trying to reestablish visibility in virtualized environments. And here mostly we're talking about how do you get packets out of virtual network infrastructure. The diagram we had earlier showed what a more traditional physical infrastructure. Of course, as soon as you start putting in technologies like hypervisors that have virtual switches in them, you start leveraging distributed virtual switching. You start leveraging technologies like virtual network overlays. Now these are virtual software-based constructs where there may or may not be traffic that can be grabbed via the traditional technique of pulling it off a wire. Taps don't necessarily, physical taps don't help you if traffic is going between two virtual machines on a hypervisor, for instance. It's difficult to understand the traffic if it's being encapsulated using VXLAN or NVGRE to move it across a network. So we started asking, we've been tracking how folks are trying to deal with and counterbalance this loss of visibility and the fact that there's traffic and activity happening that needs to be visible for network operations and security operations purposes, but isn't because the traditional techniques don't work. So here's a list of some of the most common techniques that are being used currently. It's not an exhaustive list, but these are clearly the most common ones. And even they're quite different in the way that and reason you would use them. The first one here, and unfortunately the full answer doesn't show on this slide, and I apologize for not catching that. But basically the top answer there was packet analysis tools deployed on VMs for intra-host visibility. This means taking the tools that remember we showed in our diagram at the top layer, and instead of having an appliance, dedicated physical appliance, you implement them as a virtual appliance. And you drop them in on a virtual machine so that within that hypervisor you can see everything that's going on just by connecting to the virtual switches, the V-switches, in promiscuous mode. So that works. It definitely gives you visibility back, but this is not necessarily a very scalable approach going forward because remember we talked about the fact that there are 3 or even 4 different types of analysis tools being used in the average shop today. So that would mean you'd have to have 3 or 4 virtual machines on every hypervisor, and that even if the cost of those incrementally is very low, the administrative load starts to get untenable very quickly. So very tactical and in use by a lot of folks because that was the first approach that most of the analysis tools vendors offered to solve this visibility issue. What's gaining more momentum is actually the second and third lines here, where tools are, the actual more traditional techniques are being used to simply get a copy of the packets out of the virtual environment so they can be added into the visibility layer of fabric and forwarded to an NVC or an MPB. So there's 2 techniques there. There's span or port mirroring from the virtual switch. And again, the full answer here was span port mirroring from the virtual switches themselves. This is at least reestablishes the span type option. Again, as we talked about before briefly, there are still some architectural limitations to that. Perhaps a better answer is the use of virtual taps, and the virtual taps can be implemented as a single VM, very lightweight VM, that will be on a hypervisor, grab a copy of packets, and send it out a physical NIC so that it can be picked up and used for multiple tools. So either of those techniques are at least moving back towards the traditional approach. The last one at the bottom, which reads in full, header stripping for overlay encapsulations, is really more a technique that you need to have on hand if you're starting to use encapsulation and tunneling. And there are many different tunneling protocols out there. A great example, and the one that's growing most quickly, or at least is getting a lot of attention right now in the enterprises, is virtual network overlay types of protocols, things like VXLAN, NVGRE. When you have that traffic, it looks like it's going from point A to point B, but actually it's an encapsulation that's terminated at point A and point B, and the traffic itself is actually going from point C to point D. So you need to understand exactly where that traffic is going. The answer is to take a look at the packet streams and strip the headers. So it looks like that's not a very popular technique, but it's a little bit tricky, because in this research, it was about 35% of the respondents said that they were actually using these technologies, the tunneling themselves. And so those who were using the technologies also were very interested in NPV's capabilities for stripping that right back off for analysis purposes. So we expect that lower bar to actually grow pretty aggressively in the next couple of years. So bottom line is it depends on the virtualization technology that's in use. There are a number of different ways to reestablish this, and you have to go and take some or multiples of these approaches depending on what your environment looks like.
Yeah, Jim, I was going to just add a comment on the last part. I think part of it is the adoption ratio, right? And if you look at, there's so many different flavors of virtualization or hypervisor, but if you look at the majority of the ones being used, I would say it's probably somewhere between VMware or Cisco's implementation of, 1000V or Nexus 1000V switch. And the reason we're seeing that header stripping, and we actually seen customers, and they actually came back to us and said, hey, well, you can remove, tags, as we talked earlier, right? So, well, this is a tag. Can you help us filter on the virtual interface? And then these tools that we have, like, the DPI or performance monitoring tool, don't understand this, this tags. Can you remove it? And that's what we did for them, right? We removed the tag, the VM tag, and then sent it to the tool for the specific traffic based on the virtual interface. And it was a very low cost, low impact way of doing it, leveraging the infrastructure they already had, right? The MPVs were in there, and we were able to just take the traffic and remove it. The other part is, like you said, is the more you add into the hypervisor, the more complexity it is. The more people have to be involved by adding a shim in there. So there's definitely a lot of ways to deal with that. It's just a matter of the cost that you have to endure to put that visibility into the virtual fabric, if you will, whether it's a VM or whether it's taking traffic and working with the hypervisors that they're already providing these virtual spam ports and leveraging their APIs to take that traffic up and send it to the MPV or network visibility layer, and then leverage existing infrastructure you have.
Excellent. Thank you, gentlemen. Before we move on to the next slide, we've got a great question here from the audience. So the question is, I see a trend of organizations moving processing into the cloud to take advantage of software as a service. Unless the cloud providers are going to offer these tools and will share their data with you, how do you monitor this aspect of the business?
It's a very
good
question. Right?
Yep. And it's sort of a step beyond what we've talked about here in dealing with virtualized environments. The answer is going to be, it depends. Right now, there's in most cloud settings, there's not a lot of opportunity to go and grab exactly what's going on between elements in the cloud, because you don't have access certainly to the physical infrastructure. And depending on how sophisticated the cloud provider is, you may or may not have much real opportunity for making sure that you're able to capture traffic between VMs that you're hosting in the cloud. So most folks today are simply trying to make sure that wherever their jump-off point is to the cloud, they instrument there. They make sure that they're watching whatever's heading up to the cloud. At the last possible point, they can see where that goes. This works for infrastructure or as a service type offerings. It doesn't necessarily help you with SaaS type offerings, but that's less of a concern typically. It's usually more infrastructure as a service cloud offerings. There is some improvements in the sophistication of cloud operators themselves, though, where you can actually specify virtual network connectivity within the cloud environment, where you're putting your especially when you've got multi-host workloads and in ecosystems you're going to host in the cloud. That gives you the opportunity to also include in your path some element that's going to be there specifically for visibility and monitoring. So I don't know, Tony, you're hearing anything else from your end?
Yeah, something is interesting is, well, the cloud service providers, if you look at it from their view from their end, is not much different than what the enterprise has to do. They have data centers and they have servers and they have tools and they have networks, right? So one of the things that we've been talking to some of them, is this idea. I don't know how much or how they're going to provide it, but certainly they can leverage the same approach of taking access to traffic. The challenge for them would be, segregating this traffic, which the filtering actually helps, keeping, traffic from, customer one separate from customer two, send it to the right tool set, the right DPI, and then if they can create a portal on top of that traffic and, provide those measures that you want, the KPIs that we were talking about earlier, the visibility into the quality of, service and or even the security aspects of it, then I would envision something like monitoring as a service to be offered by these cloud service providers, right? So you do get the security or software as a service, and then along with that, why is it they couldn't provide the monitoring as a service at some fraction of the cost, right? Which they would synthesize the traffic that you care about, give you the portals with the KPIs, and they could then leverage the same kind of approach in getting access to the data, add the right DPI tools on top of it, and basically then give you the measures that you want. That's a little bit further in the future, but I think we have certainly have those conversations with many of these, service providers or MSSPs, if you will.
Excellent. So here we get back to the packet visibility slide, but we've got a little more information added up here. So what are we talking about now, gentlemen?
Yeah, getting back to the key challenges for IT organizations, and I mentioned I really like this layered chart because it really explains a lot of things. I want to talk a little bit about this from two different angles. One is the enterprise space, and one is the carrier IT, communications service provider IT space. As we mentioned, in terms of the challenges, network complexity is increasing. Web cloud services need to be considered. Executives want business intelligence. Marketing wants customer behavior. Support wants insight into customer issues. And so IT departments I've seen are challenged with, they really need, in order to be able to solve these problems, this overlay. And it's really, you can call it packet visibility overlay, but that means something to the IT people. But the executives and management are going to scratch their heads trying to figure out what you're talking about. I like to call this slide kind of an analytics overlay on your IT network. And what that means is the red box at the top, the business solution monetization pieces like capacity planning tools, threat detection, big data, small data analytics, they really can't operate without getting access to the right data. And the more networks are complicated, the more remote areas traffic needs to get pulled from, pushed up through the packet analysis and monitoring pieces up to the business solution analytics so that you can have an effective, complete picture. If you don't have the overlay, then you can't get the complete picture. So, when IT starts writing purchase orders for box A, B, and C, the purchasing and management sign-off people are asking themselves, we just bought this analytics application. Why do we need all this other stuff? Well, this is a really good diagram that shows why you need the other stuff. Now, from the carrier space, they're dealing with a lot of the same things, but some interesting trends we've seen is, of course, they need to be regulatory compliant. So that's getting access to voice and data for lawful intercept purposes. But an interesting innovation is the evolution of network as data. You might have heard of this. It's basically how communications service providers can utilize the data on their network to understand their customer base, their demographics, as a whole, what kinds of services that their demographics want to see. So that implies a lot of overlay onto the network and information being pushed up to these business intelligence analytics solutions. And of course, they have the operation, maintenance, customer support experience stuff too. You really need two paradigms to achieve this. One I call the storage and retrieve piece, and the other one is the real-time identification piece. if you have the packet visibility layer, as you can see in this picture, you can have the storage piece like packet recorders that typically are just logging everything in case you need it later. And at the same time, if you have this packet visibility layer, you can do the real-time piece, which is performance monitoring, deep packet inspection, security, those kinds of things, so that you can do those things with the packet visibility layer in piece, and you get load balancing and all that kind of happy stuff. And then the layer above is a lot of times these analytics components are either relying on a combination of the recording storage piece and the real-time piece to generate alarms. And so I think this is a really good architecture in terms of a recommendation to how IT people should deal with this. We've seen successful people start small and go big. Like, just worry about the small data, focus feature set, and implement that. The people we see most often fail are the people who are going after the massive big data analytics, and it gets very confusing with lots of inputs, and then they kind of end up without a real clear plan. So that's just kind of the insight in terms of what I would call the analytics visibility overlay.
Is it safe to say in this slide that the packet visibility layer becomes kind of a normalization layer for how all these security tools are going to access the network data?
Yeah, I think I'll let Tony comment after this, but yeah, I think that's the way the analytics software looks at it, right? The analytics software doesn't work. They're just assuming that all the data that they need to do their job is going to get to them somehow, some way. And so without the normalization, you end up with a lot of wires going everywhere to be able to deliver that.
I would just say that, at the end of the day, what I see our job as the network packet broker is remove the cost and the complexity associated with acquiring the right packets, right traffic, and intelligently deliver the right set of data to the right tools. Now, that delivery, as Curt was talking about, it can be synchronous, meaning sending packets up to the tool so they can do it real time, but also as we get into bigger data, bigger volume and varieties, is this whole idea of asynchronous delivery, whether it's, packet recorders or whether it's your MPD being able to encapsulate the right PCAPs and write it to a disk store for you over, common protocols like FTP or down the road iSCSI. Those are things that we are worried with, right? Really offloading that. So normalization would be a very good way of saying that, because then the analytics layer doesn't have to worry about, well, now I have to process every packet just to get what I want. We deliver that level of optimization, whether it's to increase your network intelligence, whether it's to accelerate security intelligence, and do it in a way that actually provides service assurance for the network guys as well as the security guys in this case, right? So network guys no longer have to be worried about adding tools online and, paying the penalties of, points of failure or latency, and the security guys can add the different layers required to do defense in depth to achieve their level of service assurance that they need. That would be the summary I would leave you with as far as, but I think you said it best. I think normalization of it is really that. It's a normal thing. It's a perfectly natural, normal thing to get packets, and send it to a tool. I don't have to worry about it. This is my infrastructure.
Yeah, and I might even add that the analytics tools just simply won't work in many cases. It's like drinking from a fire hose. The analytics packages are geared towards specific data rates, specific rate of consumption, and without the intelligent feeding of those tools, many of them just simply won't work.
Perfect. Thank you, gentlemen. With just under 10 minutes left, we've got one last question for the panel here. The past and current methodology for companies to identify, assess, and respond to threats has been very reactive. What do companies have to do today to take a more proactive approach and regain IT security response agility?
I think I've pretty much, covered, and I think you heard various different aspects of both from Curt and Jim. But certainly one of the ways we've seen is if you look at this MPDs to help that, there's probably other ways. I mean, if you have the right people that you can devote and start doing a lot of advanced functions with OpenFlow, and you jump on that bandwagon, certainly some of these feature sets could be done with OpenFlow. So I'm not going to, that could be a whole different webinar. And, I just know that, yeah, it's possible. What has been proven out there, as you've seen the adoption ratio, is that the MPB has been designed to solve this problem. It started tactically. We certainly took a strategic approach of it to be able to, provide this acquisition, the visibility across all your network layers, LAN, WAN, or, cloud boundaries, public or private. This connectivity between these network packet brokers should be able to support both encapsulation and encryption as needed. So ultimately, whatever solution you have out there, it needs to provide 100% end-to-end visibility. See any packet from anywhere, send it to any tool, anytime, including ability to see inside encrypted tunnels. It should be able to, allow the IT on both sides, service providers and enterprises, to regain their agility, to evaluate tools very rapidly, whether they're analytical tools, forensic tools, security tools, and really shrink that POC cycle and, again, remove that cost and complexity of the packet acquisition and reduce the OpEx associated with that so you can go and do what you need to do. That's that level of, acceleration, or an optimization we're talking about. We need to be able to shift the game, from being a reactive model to respond to these advanced threats to a more proactive. We need to start learning about that which we don't know. And the only way is to look at these new tools that are out there that help you look at it from a behavioral or, payload, when it detonates in your environment and, the payload is encrypted and whatnot, they need to see everything, the beginning, the middle, and end. So it's more of a multi-stage, multi-vector view, and being able to validate those things way ahead of time, instead of something happened, now go ahead and get something like, just advanced malware detection tools and now rapidly deploy it and take downtime. So shifting that to proactive, this solution should allow you to help you achieve that. It needs to be scalable, right? We don't want to solve this for 1G and now 10G, and then some people go to 40G and some people are going to jump directly to 100G. Well, the paradigm, is shifting, right? It's one thing to analyze 1 gig of, traffic and take some portion of it. Another thing is to look at 40 gigs and then ensure, make sure that those analytics, those DPI cycles can scale in a way that is feasible. Those are not cheap tools. So whatever it is, it needs to be scalable. And obviously, at the end of the day, we need to keep in mind that operationally, we both sides, security, as well as other businesses, web application, application people who operate and support the SLAs for your applications, as well as the network guys who have to respond to both of these other business units. They have service SLAs that you need to be able to provide assurance towards, right? So I think these would be some of the requirements. And certainly we have seen the network packet broker is one solution that addresses these. I'm sure there's going to be others. As I said, maybe OpenFlow, maybe other ways of doing it. But this is definitely a proven methodology that we've seen out there, and there's a very good adoption ratio. And it's not a silver bullet, but it certainly has been able to attack the initial problem, the speed and media conversion, aggregation, load balancing, and the level of packet optimization that is required to maximize and optimize your network intelligence and your security intelligence acceleration as well.
Any other comments there before we open up for questions, gentlemen?
I would just add one thing about thinking of the proactive approach as a funnel where the network visibility layer is really, what you want to do is establish kind of a normal operational baseline of your traffic, and then the packet visibility piece can understand at a rough granularity what's going on, and then anything that's outside the boundary can go up to deep packet inspection tools that can do more filtering on application layers to deal with non-normal traffic, quote unquote, and then all the way up to the analytics piece, which can flag, and then you can establish a known operations baseline and be a little more proactive when unknown bad things might be happening.
Excellent. And with that, thank you to the panel. We're going to open it up for questions. You can ask these gentlemen anything you'd like with the Ask Question button on your screen. Not everybody at once. So So while they're coming up with questions, any last comments, Jim, Tony, and Curt?
No, hopefully this was, informational for everybody, and it's really is not a single thing. We partner with many different analytics tools, and certainly working with IT Fabric has been unique in the sense that we work very closely to understand the customer's problems, and the delivery of the right packet and ensuring that the customer gets what they want once they see those packets. It's an end-to-end solution, right? So it was something that we thought that this is we see this enough in the industry, and talking to Jim, there's definitely a pattern out there, so we figured this would be a good way to have this conversation and share some of the learnings we've all been seeing by going with the customers out there.
Sure. From my chair, with a few seconds left, I think the takeaway from the EMA perspective is just that it all starts with good, reliable, flexible visibility, and that's what this whole approach to these visibility layers is all about. And you can't really get ahead of the game unless you've got a good, stable, and reliable way and scalable way to get access to the visibility you need. So that's where we see the real traction and real value and real opportunity in establishing these kind of visibility strategies.
And I think that's, from my perspective, the dust is kind of settling in some places, like packet visibility is becoming an obvious and a well-known problem that's basically solved in many respects. The things that are reaching maturity, things like performance monitoring, deep packet inspection, network intelligence are there. There are pieces out there that can be utilized, and then the thing that's emerging on top of these things are the analytics, and you'll see a very wide-ranging analytics and business intelligence applications, and I think it's going to be quite a while before the dust is settling on the applications, and it's really up to you folks in the audience to figure out what features you need, work and collaborate with the industry on those kinds of things, so that you're getting actionable intelligence so you can solve the problems that you've got in your organization.
Fantastic. Well, it doesn't look like we have any questions coming in, so I'll go ahead and thank the audience for participating with us today. That was fantastic. And thank you, Jim, Tony, and Curt. I know I learned a lot.
Thank you.
It was a pleasure.
Thank you, Jim. Thanks, everybody.
Cheers.